Good morning to all of you. In the previous lecture, I have discussed the concept of Gauss law, which states that flux through any closed surface is equal to the charge enclosed in that surface divided by free space permittivity. We have also discussed the validity of Gauss law, whether the Gauss law is valid for all surfaces or only for symmetrical surfaces. And I have already discussed that how to apply a Gauss law. So there it is basically 4 to 5 step process, and these process are means we have to find out what is charge enclosed, we have to find out what is E flux through any closed surface, and then evaluate the integral. In this lecture today, I am going to discuss the concept of Gauss law and through a problem, or in another word we can say that how to apply Gauss law or application of Gauss law, means using Gauss law how to find out the electric field. So let us take the simplest case, that if we have a uniformly charged solid sphere, if we have a uniformly charged, so if we have a uniformly charged solid sphere, let's say this is the information, that we have a uniformly charged solid sphere having charge q, radius r. Then find out the electric field due to this situation. So we can find, applying Gauss law, we can find out easily the profile of electric field. So we have two different situations. In case of sphere, if it is uniformly charged, so we can find out the electric field in two different situations. One at outside the sphere, and there is inside. So we will discuss two different cases. So electric field at point P at outside, or what is E outside, what is E, what is the profile of electric field or expression of electric field at any point P which is outside the sphere. So let us consider this point P, and we can consider here, we can consider here, anywhere. So consider a point P which is outside this sphere, and we want to find out the electric field using Gauss law. So what is our job? How to apply a Gauss law? So the first step, it is, I have already told you that this is 4 to 5 step process through which we can through which we can find out the electric field by applying Gauss law. So consider, so step 1 is identify the geometry, means recognize the geometry and draw the corresponding, second step, draw the corresponding Gaussian sphere. Third, then find out the charge enclosed in that system. And fourth, evaluate flux E dot ds. So we know the Gauss law. What is Gauss law? Gauss law is simply E dot ds. If S is a surface, this is surface S, which is charge enclosed in that surface divided by free space permittivity. So E dot ds. So what is our job? The first step is identify the system. So in this case we have a sphere which is uniformly charged having radius r. So identify the, recognize the geometry and draw the corresponding Gaussian surface. So we have a sphere, so corresponding Gaussian surface is spherical surface. Let me draw the, so this is Gaussian sphere. So corresponding Oh, let me read it. Yeah, this is Gaussian sphere, and the radius of distance from this point P to center of this sphere is r. This is r, and we want to find out the electric field outside the sphere at this particular point P, which is at a distance r from where? From the center of the sphere. So applying Gauss law, identify. So in this case our Gaussian sphere is sphere, Gaussian sphere. So surface is Gaussian sphere. And what is charge enclosed? Second step, identify the geometry, draw the corresponding Gaussian sphere, and then find the charge enclosed. So identify the geometry. Geometry, what is geometry in this case? So let me, step 1, recognize the geometry, which is Gaussian sphere. Second, draw the corresponding sphere, surface. So Gaussian sphere. And charge enclosed, Q enclosed in this case is, because this is uniformly charged solid sphere. So what is charge enclosed in this surface? Let's say this is 1, this is, let me rewrite. If this surface is S1, so this surface is S2. We want to find out the electric field at any point P, which is outside. So we want to find out electric field corresponding to this S2 surface. So what is charge enclosed in this S2 surface is simply Q. Is simply Q, because this sphere is uniformly charged. So charge enclosed is simply Q. Now what is E dot ds? Third step. What is E dot ds? This is our third step. So E is electric field which is constant, which is radially outward. And if you take the Gaussian sphere, so what is ds? ds is the area vector which is always normal to the surface. So in this case, direction of E dot ds is basically E mod ds cos theta. So in this case, E and ds are in same direction. So theta is 0. So E dot ds is simply, this is simply, we can take E, this. E dot ds is simply E ds cos 0, which is 1. So E ds. And what is ds? Corresponding to if the radius of this sphere is small r, so what is ds? Is simply E into 4 pi, which is surface area of sphere, 4 pi r square. Now this is the left hand side of this integral. This is the left hand side of this integral. So what is fourth step? Evaluate left hand side. Fifth, right hand side. Evaluate and equate. So this is 4 to 5 step process. So we know what is our E dot ds is E into, let me, E into 4 pi r square. And what is our Q enclosed? In this surface, in S2 surface, because we want to find out the electric field corresponding to this Gaussian sphere, which is imaginary sphere or imaginary surface. So in this case, Q enclosed is simply Q, which is, or let me write, this is capital Q, because earlier we have defined the sphere is uniformly charged. So Q by epsilon 0. So electric field in this case is simply 1 upon 4 pi epsilon 0 Q by r square, r cap. This is the electric field, and this is the electric field due to a point charge. So whether charge is distributed throughout the surface or at the point. So this is the profile of electric field due to a outside profile of electric field due to a uniformly charged solid sphere of radius r and charge is capital Q. I hope it is clear. Now we have a second situation. We can find out the electric field inside at any point this sphere. So second case, okay, let me, so again we have a sphere whose radius is capital R. So we want to find out electric field. Second case, basically E inside. In the same situation, we have to find out what is the profile of electric field at any point which is inside the given sphere of radius R and charge Q. Again we have a charge. So what is our job? Again we have to apply a Gauss law. And how, I have already told you how to apply the Gauss law. Identify the geometry, draw the corresponding Gaussian surface, evaluate E dot ds, find charge enclosed, and equate the left hand side and right hand side and rearrange the equations in order to find out the electric field. So consider any point P which is inside in this case and draw the corresponding Gaussian surface. Again the Gaussian surface is Gaussian sphere, and we consider any point P which is again at a distance R, and the inside distance is entirely different from the outside distance. So we can write it as R1 R2. So this is, again now we want to find out the electric field inside the Gaussian sphere. Again we have a Gauss law which is E dot ds is equal to Q enclosed by epsilon naught. So what is our left hand side and what is our right hand side? So in the same case, the first step is identify the geometry which is and draw the corresponding. So we have already completed our second step. Our third step is evaluate. So 1 and 2 is over. Third is, what is, we have to find out the expression of charge enclosed. In this case, what is charge enclosed? We know that the charge enclosed is, in this case is, in earlier case simply charge enclosed is Q, but in this case we have to find out the charge enclosed in this imaginary surface. Instead of this sphere, instead of this real sphere, we have to find out the charge enclosed in this imaginary sphere whose radius is small r. So we have to find out the volume charge. We have to, at least we should know what is charge density and what is the volume of this region. Then we can find out the charge. So charge enclosed in this case is volume enclosed into charge density of this region into, let me write it here. So charge enclosed is volume enclosed into charge density. So volume enclosed into, what is the volume enclosed in this surface? This is a sphere. If radius is small r, so in this case volume enclosed is 4/3 pi r cube. And what is the charge density? Let's say the charge density is rho in this case. So this much amount of charge enclosed, which is the expression of charge enclosed in this case is entirely different from the earlier case, because in earlier case we have find out electric field at any point P which is outside, and we draw the corresponding Gaussian surface, and the charge enclosed in that case is simply Q. But in this case we want to find out the electric field inside the real sphere. So we consider is a point P which is inside the sphere whose distance from the center is small r. So we want to find out the volume enclosed in this imaginary sphere or Gaussian sphere, and then multiplied by the charge density. So this is charge enclosed. And what is E dot ds in this case? Again simply E ds cos 0. Why it is cos 0? I have already explained. Because electric field is radially outward, and if you take any surface, so area vector corresponding to that surface is simply normal to that surface. So direction of E and direction of ds is in same direction. So when two vectors are parallel, the angle between them is 0. So using that concept, this is 0. So electric field is simply E. And what is surface area total? If you integrate, this is that area corresponding to a small element. If you integrate, so you will get the total area of this region is simply, if it is sphere, so we have 4 pi r square, 4 pi r square, which is left hand side. This is known as left hand side and this is known as right hand side. Now putting the value, this is left hand side, which is E into 4 pi r square, and what is 1 upon epsilon 0. Charge enclosed in this case is volume enclosed, which is 4 upon 3 pi r cube into density. Now rearranging this expression, 4 pi r square will cancel out, and we have one more r. So electric field is simply rho r by 3 epsilon 0 r. This is inside. So this is the profile of electric field inside, and we have a profile outside, which is 1 upon 4 pi epsilon 0 q by r square r cap. So this is inside and this is outside, and this is the way to find out the electric field. So depending upon the situation, we have two different profile of electric field. In outside case, electric field is in outside case. So we can see that for outside case, electric field is inversely proportional to 1 by r square, and for inside, this is directly proportional to r. This is directly proportional to r. So this is a statement question again, or this is objective type question. What is the profile of, what is the proportionality of E with R if the electric field is, or in another word we can say that the electric field is inversely proportional to square of distance when it is outside, and it is directly proportional to the distance when it is inside, and we can plot this potential field. So this is very important expression. For sphere, we have two different profile of electric field. Outside we have different profile, and inside we have a different profile. So let me draw the sphere. So plot of electric field with distance with r, or variation of E with r. So this is our sphere. If you plot it separately, what is the profile? Electric field is outside is simply, this is r, this is like that, 1 by r square, and for inside it behaves as a, at r equal to 0, electric field inside, it behaves as a straight line. It behaves as a, if you plot it separately, so we have two different profile. So electric field is behaves as a, follow this profile 1 by r square, and if you plot this inside E in, so it behaves as a straight line. And if you plot this, now plot the variation of E, the combined effect of electric field for the case of inside and outside. So what we have? So this is a sphere and this is distance, which is r, and this is electric field. So we can at the center of a sphere means inside. So from the center of a sphere to the surface, we have three different, this is very important questions, that plot the variation of E with R. So variation of electric field for a uniformly charged solid sphere of distance or radius R. So electric field inside means we can take point here, here or up to the surface So electric field behaves as a straight line or linear behavior of electric field with distance from where up to the surface. But after this point, this is O, this is O prime, and this is point P outside. So we have three different situations. At the center, from center to the surface, electric field behaves linearly or it behaves as a straight line. If you go beyond this surface or beyond the surface of a sphere, then what is the profile of electric field? Electric field is directly outside is governed by 1 by r square profile. So we can up to this surface, this behaves as a straight line. Electric field behaves as a straight line. But if you take any point here, just outside the surface, here, so it behaves as it follow the profile 1 by r square. So in that case, this is simply outside the sphere, it behaves as this profile. So the combined plot of E for the case of inside and outside, this is correspond to outside and this is correspond to inside. I hope it is clear to all of you. So this is the combined effect of electric field, and this is all about the electric field variation, electric field profile or electric field expression for a uniformly charged solid sphere at any point P which is outside at any point. Let me write, this point is Q and this point is, so this is Q and this is P. So at any point Q which is inside, so for inside we have this profile which is rho r by 3 epsilon naught RQ, and outside at any point P which is 1 upon, which we have such a point charge simply. So electric field at due to uniformly charged solid sphere at any point outside we have such a point charge, and inside it behaves as it follow the profile of this, which is linear profile variation of E. So it's all about the electric field due to a uniformly charged solid sphere. So there are n number of questions, n number of objective questions. So just go through this and try to understand the concept of Gauss law for the case of uniformly charged solid sphere. Thank you.